So like, I'm actually gonna.
Oh no, I was struggling yesterday.
No, we aren't.
All right, so you don't have any particular questions about this?
Let me get my paper. I can't even mind. I'm not even there.
You're not?
All right, what question we got? Okay. I got a few. I got 15. Wait, I'm not
Just
gonna
let me
get
repeat
16.
this, like, don't even, that's
I hope you listening. I'm gonna just start naming off, so, cause I'm
It was like, are you okay? No, I'm literally like.
But basically like this whole page, see this?
Rams.
That whole page. That's okay.
My friend and.
Give me a number.
14 down.
Not even her.
14 down.
14 down. Like 14 is not that bad, but 16 I got a little bit confused with said transition metal.
Ashley, how many did you do?
Huh? How many did I do? I did all.
How many?
There is.
All right, here we go, number 14. We're looking at the multiple choice practice. I request 14 down. I don't know how many that's gonna be. We'll start with 14.
There's 28 in all.
Which one of these represents a atom in an excited state? That's A. What was the problem with that?
Oh no, I just had to start from there because it's at the beginning of my paper. It's really these, the
Which ones do you have a problem with?
19 down.
19 down, okay.
Wait,
Wait,
can we answer this question then?
14 is A,
Okay.
It's A, right?
Alright.
Okay.
all right.
Wait, that has 4 valence electrons.
That's
Let's see.
B.
15 is B.
Yeah.
Yeah.
Okay.
The
Okay,
transition.
it's got 2 in the S and 2 in the P. Right. Transition metal, this is somebody in the D block. It's gotta have D electrons, so
Okay,
that's
so
D.
that's just automatically D.
Number 17,
Wait. No, what's going on?
number 16. Transition metal, that's the D block elements.
So just all the D block elements are transition.
Another
elements?
name for D block elements.
I need to write that down.
17, which electronic configuration represents atoms of the element having the highest second ionization energy? My first guess would be one whose second removed electron is a core electron. That would be C.
Wait, I'm still trying to process the
Say
question.
that again.
Wait, what do you mean core electron?
What do I mean by core electron?
Yeah.
Who knows what a core electron is?
The core electrons, let's say you have 3s and 3p. Those
A
would
whole lot
be,
quicker answer than that. It's not the valence electrons.
it's not the valence electron, it's the things that are
Answer,
not the
answer
valence
this. That's
electron.
the answer.
Second most.
It's not the valence electron.
Oh,
Okay.
Things that aren't the best.
All right, so
5 minutes in class.
valence electrons get removed first, right? Last one in, first one out, okay? There's going to be a much higher ionization energy if you try to remove the core electron than any of the valence electrons. So in a question like this, which electron configuration represents atoms of an element having the highest second ionization energy? It's going to be the one whose second electron to be removed is a core electron. That's C.
Wait.
Oh, I see what you're saying. Like, do you just mean it's in a different energy group than the other one?
I mean, it's not a valence electron.
That is not.
Core electrons are the ones that are not the valence electron.
Okay. Okay, I get it. Right there.
Element C has only one valence electron, correct?
Correct.
That means its second ionization energy is going to be very high.
Which one did you say is?
C. C has one valence electron. So its second ionization energy is going to be very high number.
Okay. So,
That shit's so good. Whenever you just said it like that, that makes
So in the amount, like that atom's first ionization energy is the amount of energy it takes to remove that electron. The second ionization energy is the amount it takes to remove that second. And there's a really high difference between valence and positive electrons.
That was
So,
actually.
like now when we see.
Are we ready for 18?
It only has the one valence electron, so once you can get rid of that one.
Number 18. Elements of which of the following have most nearly the same atomic radius? My first guess would be things that are right next to each other within the same period. Do we have any of that? Looks like A. Everybody else is in a group together. They're going to be drastically different. So
Are we gonna get a periodic table on the
yes,
exam?
yes. You're getting as bad as Grant.
So over.
I mean, like on the exam.
Yeah.
Wait, are we on those?
Number 19.
Wait, what was 18?
18 is A,
Oh, that makes sense.
because they share a period together. They have different radii, but it's slightly different. It's not drastically different. Okay. B, C, and D, those are all in the same group with each other, so they're going to have drastically different radii. Number 19. All of the following statements concerning the characteristics of halogens are true except what? So that means we're looking for a false statement, right? Taking one at a time. First, ionization energies decrease as the atomic numbers of the halogens increase. That is a true statement. B, fluorine atoms have the smallest radii. That is a true statement. C, iodine is more reactive than bromine. That is a true statement. That is a false statement. I'm sorry.
Oh my, what?
Hang on a minute. That's a false statement. All right. D, fluorine is the most electronegative of the halogens. That's a true statement. Okay, so reactivity. I don't know if we mentioned that one.
Nope.
Fluorine is the most reactive nonmetal. Francium is the most reactive metal.
And then Francine, where is that?
Where's that?
Bottom left-hand corner.
Francine?
So that's is the most
87
reactive metal?
That's the same as, or like the same two elements with electronegativity, like fluorine is the most electronegative and francium is the least electronegative.
Yes. I don't think that, is that a question? Or?
Well, that was
Kind of like a
Most
statement.
clarification more than anything.
You said fluorine or
Her. That's all I can say. Just like her.
Okay, so the smaller, more electronegative nonmetals are more reactive.
Can you repeat that?
Smaller, more electronegative nonmetals are more reactive.
Smaller what?
Three. You got one word out of that? Smaller, more electronegative nonmetals.
One more time.
Smaller, more electronegative nonmetals. All right, now we're going to flip it around. Here we go. More reactive. Y'all don't,
Are more reactive?
yeah. Y'all didn't do this in elementary school, did you? Take recitation?
What? I did PowerPoint.
Yeah, that's bad. That's bad.
Oh, wait a minute.
Because they don't,
What was that?
that's so bad. All right, now we're going to flip it all around.
Okay.
Larger, less electronegative metals are more reactive. So just everything's opposite.
Except for more reactive.
Everything's opposite, for the opposite reasons.
That would be less reactive.
Less electronegative.
Larger, less electronegative
Think
metals.
about it, man.
Are
giving the
more
reasons
reactive?
for things to be reactive. The reasons for metals are opposite for the non-metals.
These are also more reactive.
Yes.
I said less large.
Less larger.
My brain, Caleb.
Y'all wonder why y'all are.
Caleb.
All right. Number 20.
Oh, Lord.
Wait, the larger less electronegative.
The opposite. It's the opposite. The opposite of what you just wrote down.
Are not more
Except that part. I said that already.
Can you
Well, I didn't
shut
hear
up
you.
for a second so I can finish writing something? Okay.
All right, I got you, Mr. Cooper. I got you. Let's see. So it decreases. So electronegativity decreases this way, right? It decreases.
Did we go over
That's why
that?
iodine.
First ionization? Did we go over the first ionization energies for decreases?
No.
In drastic detail.
Okay.
Number 20. Number 20. Let's pay attention so we don't have to ask unnecessary questions.
Mr. Peddle.
Pay attention. Pay attention. Pay attention. Focus. Focus for just long enough to read the question. The effective nuclear charge experienced by the outermost electron of sodium is different than the effective nuclear charge experienced by the outermost electron of neon. This difference best accounts for which of the following? Okay? Doesn't have anything to do with their melting points, doesn't have anything to do with their isotopes, nor their density. Has everything in the world to do with sodium having a lower first ionization energy than neon. Answer is D. Number 21. The first ionization energy of magnesium is 738. A good estimate for the second energy is what? A number higher than 738, but not ridiculously higher. So A and B are out, right? C is reasonable, D is too big. So the second ionization energy of magnesium is removing a valence electron, correct? So it's going to be higher than 738, but not that much higher. It's not going to be 10 times higher or nearly 9 times higher, as answer D is. That would be if it was a core electron. So it can't be A and B. So it's between C and D. Since it's a valence electron, D is the most reasonable answer.
The way you open that one, that scared me.
I feel like every bit of knowledge in my brain ceases.
Number 22.
You sound like
Trying to maintain calm.
Are we
I'm
pushing you
taking
that bad?
deep breaths between every statement.
Are we pushing you down that bad?
Making sure all my words are over 4 letters.
I can't.
Which of the following is the reason that ionization energy generally increases from left to right across the first period of the periodic table? It's because of an increase in effective nuclear charge. Where is that at? Okay, well, A is true also. There we go.
Wait.
Wait, so
Wait
wait.
a minute, I can't, I'm reading too far away. Give me a second. Let me read it careful because it's a little blurry from back here. Just give me a second. All right, let's see. It's D. There we go. There it is. Okay.
Okay, wait.
Can you explain why? Elaborate? Can you like elaborate?
That is why. That is, the answer is why.
Back to the nuclear
The
charge.
question is why. The answer is the reason why.
Oh.
We have beat that. We have beat that horse right there to death. That horse has been beat to death. It's buried. It has no. It's gone. Like we have beat that to death.
Can I say the next one? How you say it? Number 23.
Wait, let me do it like the pacer thing.
Number.
You're doing it like the pacer thing. That's funny. Okay.
Are we your favorite class today?
That's
The most
24.
interesting.
24 minutes you so bad.
Now you know why I don't build in time for review days.
Because it leads
So
to stuff like
this is
this.
so pointless, yeah. All right, number 23. What is the best explanation for the decrease in first ionization energy moving from beryllium to boron?
Wait,
Because it's a T1.
let it decrease in first.
This is an exception to the trend, right?
Yes, this is group 2 to 13. You said it's an
Yeah,
exception.
this is an exception to the trend.
What's
So
it
we're
gonna
looking
be?
for something to do with p electrons not penetrating the nucleus or easier to remove
Is it
or
B?
something. Which one did you say? I haven't read it.
B.
B is in boy.
D.
D is in dog. The electrons of
B is in
beryllium are
David.
located in 2s, which is closer to the nucleus and thus harder to remove. There you go.
Yeah.
Is that much choice? You did it faster that time. You said, huh? Number 23. This time, you need to go. Number 24.
No, but see, this is crazy.
Do it faster, step on.
I bet you easy.
Drag out the number and then say 24
I'm going to
fast.
bring a bag of rocks and stuff. Start chunking
Can we
rocks.
give, some people that don't say that do it bonus points?
It might be
Yeah.
bonus points for the least annoying student of the day.
We out, Ashley. We out. We out.
I'm not gonna let you down.
24. The table below shows the first ionization energies of element X in kilojoules per mole. If Y is a halogen, which compound will it make with element X? So element X, according to that chart, has how many valence electrons?
Sorry.
Two.
It has 2,
Why?
Now, how I got that, I don't know.
because it went from 738 to 1450, and then it jumped way up to 7730, right?
Yeah.
What?
It's not like those aliens from Toy Story.
Oh, wait, what's that thing? The aliens from Toy Story.
Yeah.
We love you. You are our heavenly father. Or like, we love you. You are our father. You never heard of that? I'm gonna pull it up after we finish this. What's the thing?
So the first phase of this question is we got to figure out how many valence electrons are in element X. Have we decided that? We agree that that's 2. Do we understand why?
Yeah.
Okay, because it increases and then it drastically increases, right? So the drastic increase is between 2 and 3. So that means it has 2 valence electrons. So a substance with 2 valence electrons is going to react with a halogen in a 1-to-2 ratio, because the halogens all have 7 valence electrons, right? Crisscrossing and all that from last year.
What is a halogen? Like,
17th column.
Wait, huh?
wait a minute.
You
Oh,
don't know that?
17th group.
Okay, take your periodic table and write this down. First group called alkali metals.
The first group?
Group number 1. Alkali metals.
Can we just get 100 already?
The second group,
Ashley's dying over there.
the second group are the alkali earth metals. Okay, so you have alkali metals and then alkali earth metals. The D block are known as transition metals.
Hey, are we laughing? Let me play the sound, please. Where it says, we love you. You are our father. You would have loved, like, please.
Group 17, group 17 are the halogens. The halogens are group 17.
Ooh-wee.
And group 18 are the noble gases.
All right. Thank you so much.
So if we don't know those little common names, we need to.
Before tomorrow, memorize.
Yes.
Memorize for tomorrow?
Yeah, I mean, just.
What's the 19 one?
There's no 19. There's not.
Wait, I'm sorry. I'm sorry. I didn't mean to say that. I don't know what I'm thinking. The
Yes, Noah.
What about the rest of the people?
They don't have special names.
Girl, we all the same, like, girl. Kayla, let me play it, please. It will make our day.
In a minute. Number 25.
All right. Wait, we didn't
answer
finish.
this.
We did.
Oh,
XY2.
oh.
What
Which
was that?
Which one has the number? I mean, the letter.
Oh, I got
That's
I got
B.
B. Okay, and that's because the halogens are always a 1-to-2 ratio.
Or that one.
Yeah, 1-to-2.
Halogens are always
No 1-to-2.
Kayla, wait. So halogens are a 1-to-2 ratio? That's okay.
That statement doesn't make any sense.
Okay, what'd you say? You
The
said something about
halogens would
1-to-2.
bond with something that has 2 valence electrons, bonds with a halogen in a 1-to-2 ratio.
Because it's, what was it, what if it was 3? Then it would be
Because
1-to-3 ratio?
What we have to memorize.
It's charges.
Who we?
This stuff.
Woo!
This, that,
That
Kayla's so
bonds
dumb.
to something that bonds.
Number 25.
this. And so then, what else?
The reactivity of the alkali metals. What group is that?
First.
Group. Very good. Increases going down the group, which is the correct explanation for this trend. Somewhere in that list of things,
Is it
should
because?
talk about the valence electron being further from the nucleus and easier to remove, but I don't know where that's at.
A. I think it's A.
I think it's A.
Yep, I like A.
Okay.
Yeah. So the further away from the nucleus, the easier it is to remove.
Yes,
I knew that, I just had to say it to make sure that I knew it.
gotcha. 26.
Hold on, Miss Caleb, hold on. I'm coming. I'm working. All right, go ahead.
Nitrogen's electronegativity value is between those of phosphorus and oxygen. Which of the following correctly describes the relationship between the 3 values?
Wait a minute. Whoa, so we got phosphorus and we got oxygen. Oxygen is the second largest electronegativity.
Nitrogen is going to be higher than phosphorus and less than oxygen. That's C or D, right?
Ooh,
So notice something here. Pay attention to this. This is important.
okay.
Okay? So right here, if you just know the trend in electronegativity, which is considered the basic thing to know, then you can eliminate A and B as right answers. Because they say that nitrogen is less than phosphorus, and that's not true if you know the trend on the periodic table, right? To get the final answer right, you're going to have to know the reason why. That's a deeper knowledge, right? Everybody see that? But knowing just a little bit, if you read the question, the answer statements, knowing just a little bit will get you to a 50-50 guess. Okay? There are numerous AP questions that are written that way. All right? They're written that way on purpose. So if you know just a little bit, if you know anything about it at all, you can get down to a 50-50 guess by recognizing 2 wrong answers. Then to pick between those remaining 2 answers, you're going to have to understand it completely, right? But 50-50 guess ain't bad, especially on a test that 55% is a qualifying score.
But would it be C?
That part I haven't gotten to yet, but let's see. All right.
Because isn't it like more professional or whatever to say less electrons instead of saying smaller?
Let's see what it says. Greater than phosphorus because nitrogen has less. No, D is probably it.
It's smaller.
Smaller. Yeah. Yeah. Yeah.
Yeah, just, I guess it's me. Because the answer.
And it's greater than phosphorus because of the electronegativity. The nitrogen.
No, the electronegativity is what's greater because it's a smaller atom. Number 27. How many questions are on this thing?
You only got 2 more.
It's 30.
Well, it's 30. I got more than 2. Not to
It's
jump
say
into
30. It's say 30.
not to jump down on your math skills again today,
I
but
was looking at this thing. and I
Ashley,
thought
what'd you get on the
that was
pre-co quiz?
a 15, see there?
I got
That's good.
No, for real, Mr. Good, I was looking at this thing
Grant,
here.
please tell me you didn't type these questions.
No, I printed them out.
She did the other ones.
That's fine.
Did you talk about them?
Yeah, that was for a good reason. I had like a really, really, really good reason.
No, you didn't.
I guess I
The first ionization energy for a neutral atom of chlorine is 1.25 megajoules per mole. And the first ionization energy for a neutral atom of argon is 1.52. Just a little bit higher, right? How would the first ionization energy value for a neutral atom of potassium compare to those values? Well, where is potassium on the periodic table relevant to chlorine and
It's on the
argon?
floor.
Comes right after it, right? But it's right after it, but it's on the next row, meaning the valence electron is on the next energy level. Okay? So I would imagine that it's less than,
Yeah.
right? Which is going to be, again, either C or D. So there we've thought about our trends and we've said, you know what, we got rid of A and B. So let's see which one has the correct explanation. Be less both because there are more electrons in potassium. No, it would be less than both because valence electrons is further from the nucleus than either of chlorine or argon. So D is the answer. But there again is an example where if you knew just a little bit, you got rid of 2 choices.
Did you say it was C or D?
D.
Okay, that's fine.
The PES spectrum for which of the following atoms would show peaks at exactly 3 different binding energies? That's going to mean it's got 3 subshells. So 1, 2, 1. So 1s, 2s, 2p. That doesn't look right. 1s. B is a sodium cation, isn't it? Yeah, that's very confusing. That's a weird question. Yeah, it's B.
It's B.
D. B. You could
One is
explain
and
that.
then
B is in boy.
I said you got to explain it.
I am.
Oh, 1s, 2s.
So the peaks on a PES graph, okay, are the subshells. There's a peak for every subshell. So the shells are 1, 2, 3, 4, 5, 6, 7, right? The subshells are S, P, D, F. So if you've got 3 peaks, you have 3 subshells, which means you got to have 1s, 2s, 2p. That's it. So which one of those atoms has only 1s, 2s, 2p?
Oh.
B. C would have 3s, which would make 4 subshells, right?
So really, you don't even have to worry about the photoelectron spectrum. You just gotta know how many shells.
Yeah. You just got to know that when you're reading a PES spectrum, each peak represents a subshell. This is just a backwards way of asking, which the AP folks are very fond of asking things in a backwards way because they know everybody learns it in one sequence and they love to spin it around, which is a good test to see if you tried to memorize your way through something or if you really understand. Which element would have a PES in which the peak representing electrons with the lowest ionization energy would be 3 times higher than each of all its other peaks individually? What means it's going to end in a 6 compared to a 2, right? So who's got 6 outermost electrons in that group? Neon does. Yeah. So the electrons with the lowest ionization energy would be those in the furthest subshell from the nucleus, right? And if it's 3 times higher, that's got to be a P6 versus a S2, right? 6 being 3 times larger than 2. 6 is 3 times larger than 2, right? So remember, the height of the peaks represent how many electrons it represents, right? So if we got a little bitty tiny peak and a little peak that's twice as tall as that, that's 1 electron and 2 electrons, right? And if the next peak is 3 times taller than the previous one, that must be 2 and 6. Because 6 is 3 times bigger than 2, right? So if we're looking at this, and the lowest ionization energy peak, meaning the one that's furthest from the nucleus, is 3 times higher than the peak that came right before it, then that's got to be an S2P6 configuration. The only atom up there that has an S2P6 configuration is neon.
Okay.
It's the only one on that list of choices.
So 2 P6.
Where did it?
That's the one that has.
6 is 3 times bigger than 2.
Let's see, okay, Mr. Cagle, I have a question. Where did we get the 2 from?
3 times higher. It's the only combination of things in configurations that 3 times, that's going to be 3 times higher.
Cool.
So it wouldn't be neon because,
It is
I mean,
neon.
it is neon, but I'm saying it wouldn't be sulfur because that 2P6.
Sulfur
right
ends
after-
in S2P2, which means those last 2 peaks would be the same height. No, I'm sorry. Sulfur ends in S2P4, which means the last peak would be twice as high. Carbon ends in S2P2, so its last 2 peaks are the same height. Sulfur ends in S2P4, so its last peak is twice as high as the one before it. But neon ends in S2P6, so its last peak is 3 times higher than the one before it.
So how would you know whether?
Well, I hadn't read it yet, so let's just see. Oh, electron affinity. We hadn't mentioned that yet. Okay.
I googled that today because
Very
I saw
good.
it on AP class.
What does it mean to have an affinity for something?
You like it?
It means you like it. Okay. So nonmetals have high electron affinities. They like electrons. Okay.
It says when an electron is added to a neutral atom to form a negatively charged ion. Is that gonna be on the test tomorrow? 'Cause
Could be. Why not?
Please no.
Just because I forgot to tell you about it doesn't mean it's not on the test.
What?
Lie. Sorry.
See?
Did you say lie?
That's lie.
Oh, you said.
So which of the following represents the first electron affinity of chlorine? So electron affinity means the element likes electrons. So this is the element plus an electron makes what? That's got to be A or B first off, right? Okay, because A and B are reactions that represent the gaining of an electron, correct? It's an atom plus an electron makes something else. So which one of those would be the first electron affinity? Well, you got to go, if you haven't given it any electrons yet, what's its charge? Neutral. And when you give it one, it becomes -1, right? So that's A. Neutral chlorine plus an electron makes chloride.
So we got, it's 49. It's 49 today.
I thought you said there were only 30 questions, by the way.
Okay, look, Mr. I didn't say that. I didn't say that.
You did say that.
I didn't say that. I
Yes, you
said
did, because I
28.
distinctly remember
She
you
said-
thinking.
I said 28.
I
But that's
said
still wrong. I didn't say
Okay,
30.
so you're even more wrong than I thought. Okay.
In my defense, I didn't even look at this
So
one.
that's
I didn't
no
even look.
defense. Number 31.
What is this?
But I'm
Where?
honestly happy we did
This
though,
is
'cause I'm-
linked in the presentation.
Okay.
Last slide in the unit's got a link to it. 31. Which of the elements above, where would it go? Or I guess it means below. Whatever, okay. Has the smallest ionic radius for its most commonly found ion. Okay, well, first off, if it's going to be small, it's probably losing, right? Well, I take that back. Hang on just a minute. Okay. So what are the most commonly found ions of oxygen? What's its most common ion? O2 minus, very good. What is platinum? Who cares what that is? That's way down the table, right? So again, a little bit of knowledge gets two wrong answers out of here. So lanthanide and rubidium are way down on the table, right? They're going to be quite larger than everybody else, correct? So we can just forget about them. Let's look at oxygen and magnesium. Magnesium is going to do what to have its most common ion? It's going to lose 2 electrons, right? Okay, which leaves it with 10. When oxygen gains 2, how many's it got? 10. Okay, so what do we have there? Oh, very good. They're isoelectronic. So the smaller one is going to be the one with the most protons. That would be magnesium with 12.
Okay, I got that one. I got that one. There's some hope. There's a little bit of it there.
So the protons.
So if you have a set of isoelectronic atoms, the smaller one is the one with the most protons. Becomes a greater effective nuclear charge.
Because that's how it is on the periodic table.
So the more electrons you have, the
And
what?
same thing about electrons.
Well, the more protons.
Protons.
The more protons it is smaller.
How many times have we said that in the last week?
Mr. Cato,
How
this is
many
the first
times
time I
have we
got
said
it.
that in the last week?
This is the first time I got it. So today is the day.
Today is the day.
I'm glad it-
We are glad.
After we finish this last one, can you name up 10 things that are not like equations, like subjects?
Whatever things we talked about, huh?
Can we talk about
A lot.
aliens?
We talk about no aliens?
We talk about aliens.
Y'all talking about aliens. I haven't said anything about aliens. Y'all
You
are talking about aliens.
throwing rocks. That's
But we're not
what
making that a test based off what y'all mumbled about in the last 2 weeks.
For bonus points.
32.
Please.
Which of the following best helps to account for the fact that the fluoride ion is smaller than the oxide ion? Well, they're both isoelectronic. That's almost the same question we just asked. Okay. So fluoride has more nuclear charge. B.
Is that the same as? So that's
Same
that's
answer as
greater-
31. Almost the same question as
So
31.
that's greater effective nuclear charge.
Can I play the aliens?
Yeah.
Please.
Oh.
What is it off of Toy Story?
Yes.
And it's the same answer.
Yes.
It ain't A, B, C.
This is so complicated. Oh my gosh, I failed it. Okay,
Oh, math.
Cato, are you ready? It's so funny.
Okay.
That's it, I'm playing. Cato, you're gonna love it. We didn't say that beginning.
Okay. How much time do we have? Like a minute or something?
No, like 4.
4 minutes?
I need to go across this whole piece of paper.
Yeah, see, like that one says. I hate how little it is. Yeah, I just looked to me a little bit.
You're gonna have a notebook for each one.
Yeah.
Answer the following questions about the element selenium. Samples of natural selenium contain 6 stable isotopes. In terms of atomic structure, explain what these isotopes have in common and how they differ. They got the same protons and different neutrons. That's the definition of an isotope. Same protons, different neutrons.
I just have the same protons, different electrons. Caleb, it's been a bad
Neutrons,
day.
neutrons. You just gave me the definition of an ion.
So,
Oh.
so I
said
am the same
neutral
proton,
electrons,
different
I'm sorry.
electrons.
You don't know what's happening.
Selenium,
Wait a minute.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. We're going to be able to write that like writing our name.
Yep.
Okay? Because if we look at the periodic table, selenium is in the fourth group of the p block on the fourth period. We ought to know that therefore ends in 4p4. So we ought to be able to backfill that without hardly even thinking about it at this point. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. Okay? So we know where it stops because we look at its place on the periodic table, right? There are going to be 2 unpaired electrons in that configuration. In that p orbital there, those set of p orbitals, you're going to have 2 paired and 2 unpaired, right? It's going to go up, down, up, up. The 2 ups are unpaired electrons.
Up, down, up, up.
Write it on your paper and look at it. You'll see it.
Write down on my paper, up, down, up.
Selenium.
The orbital diagram. The orbital diagram.
Oh.
Caleb, clock out. It's time to clock out. It's recorded. It's clocking out. You said 4p what?
4p4 is what it ends in, right? That's 4 electrons are going to go in 3 p orbitals, correct?
So it's gonna go up.
So there's going to be one that's up, one and down, one up, and another one up. That means you've got 2 pairs,
Up, down.
2 pairs,
Yeah, that's how you
2
should.
unpaired.
That's how you should.
Up,
You should say
up,
up and down,
down.
not up.
Well,
up,
reading it
not up,
left
down,
to
up.
right.
We are totally great.
Up,
Up, down. Up, down.
That makes
Go
sense.
back. It's like shadow ball.
That makes sense.
Right, come on, Caleb, we did it last year, Caleb. Up, down. Sorry, Reese.
I'm turning this camera off. Somebody's going to get hold of this YouTube playlist. I'm
Wait,
sure.
you filmed that? Yes, done.
Somebody's going to
You
write
said
this.
besides that, I got
Somebody's going to write a
three
dissertation,
I can throw out the whole
case
slide.
study, dissertation based off watching this playlist one day. Psychology. We get a PhD in psychology from watching this, or human behavior, or something.